Professor Emeritus Dick Dienstbier, take it away.
Thanks, Nick. It is indeed a pleasure to be here. I'm going to spend most of my time this morning talking about the role of love and affection in building what I call toughness. And toughness is just a fancy term that's somewhat akin to resilience, but it implies that the things that we do in life, such as expressing and experiencing love and affection and good nurturing, actually change our brain in various ways, and especially change the way in which we respond to stress and help to repair some of the ravages of aging. And those physiological changes, in turn, help us to resist both negative emotions and experience positive ones, and that's where happiness gets into this, and keep us more or less mentally sharp as we age and as we experience stress, which tends to be something that reduces our sharpness. So, we double-click on notes and have a picture of the brain, which we'll look at in a minute. First, I want to introduce you to the basic anatomy that is listed up here, and it's not extensive, and nothing is going to be frightening, even if you haven't been studying psychology in the last week or so. The hippocampus is an area of the brain, and we'll get to the picture in a moment so you can visualize these. The hippocampus is an area of the brain that consolidates memory. And it's an extraordinarily important part of the brain. It sits in the area where Alzheimer's begins, and so you associate hippocampal deterioration with Alzheimer's. But it's also ravaged by stress and declines roughly 1% a year in size once we get past around age 60 or so, unless we do things to resist that decline. So hippocampus, and I put up there just as a way of remembering what it's about. Hippos. Hippocampus actually is a nice Greek term for seahorse. Hippos remember stuff. Hippocampus, consolidation of memory. Amygdala spawns fear and anxiety. Amygdala is Greek for almond, and you can remember what the amygdala does by remembering that almonds can be bitter. I know for most of you I'm really talking down to you, but there probably are some folks who don't know an awful lot about brain parts. The hypothalamus is an area in the lower part of the brain that instigates arousal, causes the pituitary to do various things that arouse both brain and body. We're going to talk a little bit about some neurochemistry things. Neurotransmitters like dopamine arouse the brain. Often these neurotransmitters like dopamine and serotonin and noradrenaline, also known as norepinephrine, begin in the brainstem in the sense that there are some centers way down in the brainstem, just above the top of the spine, that send these neurotransmitters into forward and upward parts of the brain, the neurotransmitters that they spawn. The basic neurochemistry, neurotransmitters, dopamine is terribly involved in the things we're going to talk about because, as you probably know, dopamine is the neurotransmitter that is elicited when you take those drugs that make you feel instantly happy. The neural circuits that are associated with dopamine also tend to be in the old brain, the lower part of the brain. Oxytocin, another both neural transmitter and hormone, it's got double assignment there, is elicited when we experience affection and when we express affection, when we give somebody a hug, when we kiss someone. It's particularly elicited when women nurse their infants. It's also elicited during lovemaking big time, especially with orgasm. So if nothing else comes out of this, remember, multiple orgasms, good for you. Couple of hormones to talk about. Adrenaline comes from the adrenal glands, and it's a nice hormone in the sense that it is elicited when we experience both positive and negative emotions. It causes the liver to generate blood glucose, and blood glucose energizes the brain, because the brain doesn't use any fuel except blood glucose. Brain has no capacity to process fatty acids or anything like that. It's just there. The blood glucose is the name of the game. Cortisol is a hormone that's elicited when we experience negative emotions or threats. And it tends to be nice in the short term because it helps to energize us. But in the long term, if we sustain extensive stress, as in combat situations or growing up in a family situation that is problematic in some way, that's the opposite of nurturing, cortisol tends to damage the brain severely. It especially degrades the hippocampus, that area associated with forming memory, and it also in excess tends to degrade the frontal areas of the brain, the prefrontal cortex associated with reasoning and careful planning and what are often called the executive processes. Okay, we're up to speed on everything except neurotropins, not a term that you hear an awful lot, and I think easily confused with neurotransmitters. Neurotropins are chemicals that are responsible for building the brain in various ways. When you're learning something, such as you are as you attend a conference like this, neurotropins are elicited from the neurons in the brain that are active or activated by the learning process itself. Those neurotropins turn on, they result from genetic activity and they turn on genes. So that as you learn things, your brain actually changes form. Your synapses change and so on and so forth to accommodate that learning. So, all right. We've got neurotropins, especially the important one, brain-derived neurotropic factor, whose name you're going to never remember unless you know it already. Why is stress bad for the brain? Well, stress elicits cortisol, high levels of cortisol that come from the adrenal glands, can cross into the brain through what's called the blood-brain barrier. I promised I'd let you look at the pictures. Back up for a moment. The hippocampus is this nice sort of purple area that is really comes out of the center of the brain towards the temporal sides. That's where memories get consolidated. Those memories don't get stored there, they get consolidated there and then they get sent to other parts of the brain for storage. The amygdala, sitting in red right there next to the end of the hippocampus, is that center for negative emotions. The amygdala is strongly influenced by our affectionate activities, and we'll get to that in a little bit. The prefrontal cortex, obviously off there on the left. And that's pretty much all that we're really concerned with at this point. When I talk about the neurotransmitters being elicited first by centers within the brainstem and then circulating out to the front and upper parts of the brain, you get something of that image there as well. So, stress is awfully bad for the brain because long-term stress causes a neural deterioration in both the hippocampus and the prefrontal areas. Aging does very much the same thing. Not only does aging cause some deterioration of the myelin sheaths that allow transmission of impulses from one area of the brain to another or from the brain into the body, but also is associated with the shrinkage of hippocampus and things of that sort. But while we think of different kinds of arousal then, associated with positive states like excitement, which is rich with adrenaline, or negative states like fear and threat, strongly associated with cortisol, we recognize that we do have the mental capacity to change the nature of the arousal in our bodies in the short term. In other words, a lot of the situations that we get into are relatively ambiguous, and we can look on them as challenges, see the possibility of coping effectively by the things that we say to ourselves and the way we respond to the situations, or we can interpret those situations as threatening. If we interpret them as threatening, then we're likely to have a big cortisol response. If we have a big cortisol response, after the cortisol re-enters the brain, there's a kind of a chemical reinforcement of that initial appraisal that this is going to be a tough, bad situation. The cortisol actually increases feelings of tension in the body and in the brain. And so again, one of the things to keep in mind as we think about these things is that we do have some capacity in the short term to change the way in which we respond and the arousal that follows. I want to turn to affection and nurturing, and I want to mention very briefly a little bit of genetic stuff. Our genes change across our lifetime. We used to think about genes as sort of laying a blueprint for our development, and that our experiences ever after change the way in which our body forms and our mental capacities change and so forth. But the way in which those experiences affect us is through our genes. A child who grows up in a situation where nurturing is awful has genetic changes that cause reductions in things like the neurotropins, like brain-derived neurotropic factor, BDNF. And that brain will never be as well developed as a result of living in that awful early situation as it would have been in a better situation. Doesn't mean the kid can't grow up to be very smart and able in lots of ways, but that child won't be the child it would have been otherwise, if stress is really long-term and continuous. On the positive side, though, positive nurturing causes opposite changes. And when an animal or a human being, animals like the lab animals that are often worked with, including monkeys and rats and so forth, when an animal or a human being grows up in a situation where there is lots of expressed kindness and love and affection, that brain is modified as a result of the genes being modified, made more sensitive through a lifetime, so that it takes less to turn on the neurotropins in the brain of the child who has been well nurtured. And as a result of the neurotropins being more easily elicited throughout the lifetime of that person, we have a person whose brain is in better shape. And the person is much better able to resist stress and so forth as well, because some of the changes that occur are changes in the amygdala, where it becomes less sensitive to stimuli. Remember, the amygdala, the bitter almond, the seat of negative emotions, less easily turned on as a result of that nurturing. Oxytocin and the endorphins are elicited whenever we are involved in a situation where we're giving affection or receiving affection. There's a big lesson there. If you want to increase your oxytocin levels, which in turn kick out the endorphins, endorphins sort of the natural morphine of the brain. If you want sort of a temporary lift from those things, then, give a hug, have a kiss. Do these things legally. I don't want to be encouraging activities here that'll get you in front of places you don't want to be. But clearly the expressing of and the experience of those emotional moments elicit those chemicals. And when that happens, over the long term, the neurons in the brain change because the genes change. If you're unfamiliar with this idea that genetic changes occur across a lifetime, what's particularly interesting is that some of those genetic changes can actually be passed on to our offspring in various ways. That happens when males experience a great deal of stress, for example. because we make sperm throughout our entire life. Some of the genetic changes that are made because of the stress actually get into the sperm, and we can pass those modified genes on to our offspring. Until last summer, this past summer, we knew this because of research with animals. As of last summer, a great study just published showing that the genes of the children of Holocaust victims were modified in ways that reflected the ways in which the genes of the Holocaust victims themselves were modified. Mothers who are extraordinarily emotionally unstable, who experience a lot of amygdala activity that spawns a lot of cortisol that actually crosses the placenta and affects the developing fetus. Mothers who've been mistreated tend to pass on to their children high levels of cortisol when the brain's being formed as in the fetus, and thus to modify the genetic structure and the neurons of the brains of their children to make those kids less stress tolerant throughout their lives. The opposite, though, happily also occurs. Mothers who are not experiencing a great deal of stress, who are well balanced and happy and who have had their hug today. Remember the importance of that? Those mothers tend not to pass on any of the destructive capacities, the destructive results, tongue-tied on how to say this right. They don't pass on the high levels of cortisol that affect the brain in the negative ways. Instead, the brains of their offspring tend to develop such that they too become nurturing, benevolent children and nurturing and benevolent mothers. And so, although the mechanism for transmission of life of high stress is different from mothers to their offspring than it is for fathers to their offspring, although the mechanism is different, the result tends to be pretty much the same. And again, love and nurturing lead to well-balanced and well-nurtured offspring who themselves become good parents and so forth. Now, if I can take a couple of moments to show you some of the mechanisms. I'm going to go through this list in a fast enough way that if you're not familiar with some of these concepts, they might pass by you kind of quickly. But if you are well nurtured, if you are loved as you grow up, and even as an adult, if you experience the kinds of activities that we think of as love and affection, giving and getting, both important, you tend to have more estrogen receptors in your brain. Estrogen receptors are good because the more the brain is sensitive to estrogen, the more warmth and nurturance a person feels, particularly while raising kids, but not entirely there. If you are well nurtured, the receptors for cortisol, particularly in the hippocampus, tend to increase. If you experience a lot of stress, they decrease. The hippocampus is completely involved in downregulating the arousal associated with cortisol. If you have more receptors for cortisol in the hippocampus as a result of positive nurturing, then the brain recognizes, oh, geez, the cortisol levels are very high right now. We better downregulate that load of cortisol. Affection and love increase the density of cortisol receptors in the brain and make it more sensitive. There is, as a result of increased affection and love, more of the neurotropins, especially the one we call BDNF. And so the brain grows and resists stress and resists aging as a result of love and affection, because it directly increases the load in the brain of these essentially heroic neurotropins. There's an increase in some of the neurotransmitters in the brain as a result of the immediate experience and the long-term experience of love and affection, especially one called acetylcholine. Acetylcholine is a neurotransmitter that you don't hear mentioned as often as dopamine and serotonin and so forth, but it's involved in memory formation. If your levels of acetylcholine are low, you tend to have some problems forming memories. One of the earlier drugs, not very effective, for Alzheimer's disease was a drug that kicked up levels of acetylcholine in the brain. Acetylcholine is increased in the brain as a result of experiencing love and affection, both in the short term and the long term. And when I say short term and long term, I mean, obviously an episode, a hug, a kiss will increase the various things I've been talking about. But a lifetime of doing these things will change the genetic structure so that cortisol receptor levels increase, estrogen levels, receptor levels increase. Neurotropins are more easily generated in the brain in response to stimuli, and so on and so forth. Both short-term and long-term implications from affectionate behavior. There is increased production of the proteins that build the synapses, the connections between the neurons, the synapses. The form of synapses changes as we learn and grow and so on. The synapses also decline in various ways with too much stress, because of the cortisol load, and with aging. And so the development of the proteins that develop the synapses is another one of the long-term benefits of affection. There's a reduction in in one of the areas of the brainstem that's real important called the locus ceruleus, and also in the amygdala, a reduction in sensitivity, so that our negative emotions do not flood us with when we're in bad situations as much as they would otherwise, following a lifetime and an episode of affection and nurturing. I think that's just about enough of the sort of technical things. I want to mention one other thing that has to do with one of my interests, which is in general toughness, how to build reserves in the brain that have implications for emotional stability and for staying mentally sharp. The things that I've talked about, from affection and nurturing, all change the brain, and they change our psychological state as well. So too do things like physical exercise and mental challenge and exercise, and even things like meditation and cousin activities like Tai Chi and so forth. All of the things that I've said are based on the sort of modern neuroscience, modern research, and if you are awfully interested in all this stuff, I think there we go. I got a note in my email just last night that this book is just coming out, Building Resistance to Stress and Aging, the Toughness Model. And what I've essentially told you today is material from one of the chapters of that thing. But it's expensive. But worth it, Nick says. Thanks, Nick. Do you want to do? We're right on the Yes. How has this been part of my life? That gets kind of personal, doesn't it? Yeah. Well, I think that when I say give and get hugs whenever you can, I grew up in a family where people didn't touch. And it's taken me a little bit of my adult life to become really free with being that more physically demonstrative person that I think is healthy and good. I don't want to say too awfully much more than that. I did put on, however, I only have a couple of T-shirts that have anything to do with affection and so on and so forth. And so, since you asked the question, I show you that. It's probably too far away. What's it? Nick, can you read that?
This says, "'Tis better to have loved a short person than never to have loved at all."
There was, from back, yes. Most of the research is done with immune system cells. Most of the research is done with immune system cells because it's so, you just pull out a little bit of blood and then you do the genetic analysis. And none of the research is done with brain cells because nobody wants to donate brain cells for this sort of thing. But yes, indeed, it's exactly what I said. There are a couple of different chemical processes when you experience a lot of stress, and genes get modified so that they are less sensitive, so that they might even be permanently turned off. The process is called methylation. There's a chemical group called, there's a methyl chemical group that gets attached to the promoter region of a gene, and that's probably more technical than you wanted. The opposite is called acetylation, and it's with an acetyl chemical group that messes around with the genetic structure and makes genes more sensitive. One study I want to tell you about, identical twins, the older they get, the more different they are genetically. Sequence of amino acids stays the same, but the degree to which that amino acid can be activated. Okay, all right. I don't know if I can answer the question at a very fine-grained level, but generally speaking, the research suggests that both giving and receiving of affectionate activities elicit oxytocin, which kick out some of the endorphins, which eventually modify in a more long term some of the underlying genes. So positive benefits from both giving and receiving. When you pet the cat benefits greatly with purring and undoubtedly oxytocin and thinking very happy thoughts, although we don't know so much about the happy thoughts. And so do you. You benefit by doing it as well, in the sense that administering that kind of nurturance does change your underlying hormonal balance. Yes. Probably, but never for sure. Psychologists used to believe that whenever a disaster or road rage or some other similar thing occurred, that it was best to help people to express their feelings, move into the area where the hurricane has devastated New Orleans, and get everybody talking about it, and then that'll be cathartic and they'll all feel better. Modern approaches to this suggest that this is more of an individual thing, that for some people, just controlling it and not expressing it is much better than letting it out. And it's really hard to know in an individual case. But this is why we have NPR. We turn on the classical music and we say, oh, okay, I can handle this, no problem. Like meditation, prayer and related activities do seem to have a long-term toughening impact. There's some really, used to be that the research on meditation was, if you'll forgive me, crap, because it was done by true believers but nowadays, ever since Jon Kabat-Zinn developed what's called mind-based stress reduction type of meditation, mindfulness meditation, at the University of Massachusetts, and started spawning that around the country. We know that even 8 weeks of training of meditation can change the brain, actually causes hippocampal changes that you can measure with an MRI, for example. Similarly, there's some great Chinese research published just a couple years ago on Tai Chi, which shows very similar things. And some of that research includes things like prayer, although spirituality is not a term you see often in that literature, but you do see people who practice prayer tend to have the same sorts of changes in both temperament and underlying brain structure that you see with meditation.